In this video, we are discuss about VLAN ports. Actually, switch have two types of ports. The first one is access ports, and the second one is trunk ports. Access port is a port that is connected with host or any other device like switch or router. These are access ports. These carries a VLAN data. This carry only one single VLAN's data. Access port does not carry multiple VLAN's data simultaneously. But trunk port have a capability to switch multiple VLAN's data. For example, this is a switch that have VLAN 1, VLAN 2. This is a second switch that also have VLAN 1 and VLAN 2. If I'm connecting a port like this, these are the port, 4 ports in VLAN 1 and 4 port in VLAN 2. The same is on switch 2, 4 ports on VLAN 1 and 4 ports in VLAN 2. If I am connecting this port to this port or any VLAN 2's port, then this port can only travel VLAN 2's data. It do not travel or did not access the VLAN 1's data. So by this, VLAN 1 cannot communicate with VLAN 1. So we come with a trunk port. This is VLAN 1, this is VLAN 2. Same applies on here, VLAN 1, VLAN 2. Here I am using a trunk port. These are the trunk ports. Actually, the trunk port is a part of all VLANs. Trunk port also carry VLANs 1's data and VLAN 2's data also. This trunk port is connected to this trunk port. From this switch 1, VLAN carry VLAN 1's data and VLAN 2 data and send to switch 2, and VLAN 1 data can communicate to VLAN 1 and VLAN 2 data can communicate to VLAN 2. For differentiating VLAN 1's data and VLAN 2 data on the trunk port, the switch uses ISL. ISL is inter-switch link. Inter-switch link. Inter-switch link is a way of explicitly tagging VLAN information onto an Ethernet frame. Actually, by ISL, you can interconnect multiple switches and still maintain VLAN information as traffic travel between switches on trunk links. Actually, the working is like that. Trunk port, only the trunk port can carry multiple VLANs data. For example, this is a trunk port and this is also trunk port of switch 2. This is switch 1. When a traffic generates or comes to a trunk ports add a, you can see, add a tag to every packet of data or every frame of data. that frame defines, or you can see the frame have VLAN ID, by which on the other end, by this VLAN ID, this trunk port can differentiate between multiple VLANs data. For example, there is a two LAN, LAN 1, LAN 2, LAN 1, LAN 2. LAN 1's data sent via tag 1, LAN 2's data sent with LAN 2 tag. These two frames received on this interface, then this trunk port plays a role and checks the tags. If tag is for LAN 1, then this frame is broadcasted or sent to LAN 1 only. If tag having LAN 2 or frame having LAN 2's tag, then this frame send only LAN 2. There is actually IEEE creates a standard for trunking, that is 802.1q. This is a standard that is created by IEEE for frame tagging, or you can say it is a standard method of frame tagging. Actually, it inserts a field into the frame to identify the VLAN. Actually, A22.1q add a tag. In the tag, there are 12 bits value. That value defines VLAN ID. This 12-bit value defines VLAN's ID. If this trunk sends a tag, in this tag there is a VLAN ID field. This is the 12-bit field. In this, the VLAN ID is written down. So the other end trunk can understand this packet belongs to which VLAN. Here the term multiplexing plays a role. For example, this is a trunk link. This trunk link have multiple VLANs data on a single cable or a single path. And on other end, this single path can send multiple VLANs data. This process is multiplexing and demultiplexing. Multiple VLANs data can send via a single path. This all work is done by trunk link. So in a scenario, trunk link play a very important role.